Okay, so for this problem, they want us to find the related phase plane portrait and sketch the solutions for this planar system. And the first thing you want to do is divide the two differential equations. So let's take a look at having our dx dt is equal to negative 8y divided by dy dt is equal to 18x. When we do this division, we're going to see right away the dt's cancel out, and we get the differential equation dx dy is equal to negative 8 times y over 18 times x, which further simplifies down to dx dy is equal to, it's like negative 4 times y over 9 times x. Now from here, we think back to earlier this semester when we looked at first order equations, and we definitely want to use separation of variables for this. So we're going to have a 9x dx is equal to a negative 4y dy. And if we integrate both sides of this, we're going to get a 9x squared over 2 is equal to negative 4y squared over 2 plus c. And of course, we can multiply this whole thing through by a 2 to cancel those out, so that we get a 9x squared is equal to negative 4y squared plus a new value of c. And then we can add our 4y squared over to the other side. And that's going to give us a 9x squared plus 4y squared is equal to c. And then we could actually do a little trick from college algebra or pre-calculus. We can divide this whole equation through by a 36. And that will give us a 9, actually it's going to be x squared over 4 plus y squared over 9 is equal to a new value of c. And if you think back to your days in college algebra or pre-calculus, this is an ellipse. So if we actually graph our solutions, we see that we have an ellipse. Now, since we don't know the value of c, we really can't say it's an ellipse, but if we set c equal to 1, then we know for sure it is an ellipse, and we know that we can go out 2 places on the x-axis and 3 places on the y-axis, and we will have our elliptical solutions, which may either go like this or vice versa. But that is our phase portrait. So all of our solutions are trapped on an ellipse of this basic shape right there. And then if you put this into a program like Desmos or your graphing calculator, you can graph the elliptical solutions to this system. All right, so again, if you have any questions about these problems, please be sure to ask.